nilpotent group is nilpotent. Okay, let's see the proof. Let G be a nilpotent group. Then there is an ascending central series and a positive integer such that singleton E is equal to Z naught of G, which is contained in Z1 of G, which is contained in Z2 of G, up to so on, which is contained in Zn of G, which is equal to G. Okay, this is the definition of ascending central series. Okay, this is the ascending central series. Okay, why? Because G is the nilpotent group. Okay, that's why here the ascending central series exists such that Zn of G is equal to G. Give it as equation number 1. Okay, so we have to prove that singleton E is equal to Z naught of H, which is contained in Z1 of H, up to so on. Okay, be the ascending central series for H. Okay, we assumed that this is the ascending central series for H, where H is the subgroup of nilpotent group G. Okay, now we have to prove that there exists a integer n such that Zn of H is equal to H. Okay, when this happens, then automatically H must be a nilpotent group. Okay, we have to prove that Zn of H is equal to H. There exists positive integer n, smallest positive integer n, such that Zn of H is equal to H. Okay, from 1 we have what we have, singleton E is equal to Z naught of G intersection H, taking Z naught of H intersection with H, which is contained in Z1 of G intersection H, up to so on Zn of G intersection H, which is equal to H. Okay, from 1 we taken intersection with H in the series equation in the series 1. Okay, या इक्वेशन या सिरीज मधून जी फर्स्ट सिरीज दिलेली आहे तुम्हाला त्याचं इंटरसेक्शन कोणासोबत घेतलंय आपण H सोबत. ओके, सो Z नॉट ऑफ G इंटरसेक्शन H, Z नॉट ऑफ G हा सिंगलटन E आहे म्हणून Z नॉट ऑफ G इंटरसेक्शन H काय येणार, सिंगलटन E. ओके, and so on. Zn of G intersection H, which is equal to H. Okay, why? Because Zn of G is equal to G, and G intersection H must be equal to what? Yes,
H.
because H is the subgroup of G. Okay, so now we shall show that Zi of G intersection H is contained in Zi of H. Okay, so clearly we have Z naught of G intersection H is equal to Z naught of H. Okay, which is equal to singleton E. Yes, what is the value of Z naught of H? It's singleton E. Okay, so we have Z naught of G intersection H is equal to, this is the singleton E, but singleton E is nothing but Z naught of H. Okay, it wasn't clear, understand?
No, sir.
Okay. Now we have taken X is the element from Z1 of G intersection H. Okay, and we have to prove this X must be belongs to X1 of H. Why? Because here we assume, look at here, Z1 of G intersection H. This is the nothing but Zi of H. Now we have to show that this one Zi of G intersection H is contained in Zi of H. One साठी काय येणार, Z1 of G intersection H, it's contained in Z1 of H. We have to prove this one. Hence we taken X is the element from Z1 of G intersection H. What it means, X must be belongs to Z1 of G, and also X belongs to H. Okay, but by the definition of Z1 of G, okay, what we have, X inverse Y inverse belongs to Z naught of G. which is equal to singleton E. Okay, this is the definition of Z1. In the previous lecture, we've seen that what is the definition of Zn? Zn of G is equal to x belongs to G such that x inverse G inverse belongs to Zn minus 1 of G. Put n is equal to 2 here. So Z2 of G is nothing but x belongs to G such that x inverse G inverse belongs to Z1 of G. Put n is equal to 1 here. What we get? Look at here. Put x is equal, n equal to 1, then x belongs to Z1 of G and x belongs to H. It implies that x, y, y inverse belongs to Z0 of G, which is equal to singleton E, and x belongs to H for all y belongs to G. हा y कुठून येतोय? Y आणि y inverse G मधून येतोय. Okay, for all y. Okay, this is the definition of Z1 of G. Now look at here, which implies that x y inverse belongs to Z0 of G, which is equal to singleton E, and x belongs to H for all y belongs to G. This step will which implies that x inverse y inverse belongs to H, okay, which is equal to singleton E, and x belongs to H for all y belongs to H. Look at here, because H is contained in G. Why? Because H is the subgroup of G. Y च्या प्रत्येक एलिमेंट साठी तो G मधल्या प्रत्येक एलिमेंट साठी तो ट्रू आहे. It implies that, but H is the subgroup of G. Hence, for any element of H, this statement also true. Okay? Any difficulty? इथपर्यंत काही अडचण? For any element
No,
Y
sir.
belongs to H also is true. It means that, but it is the definition of what? H, Z1 of H. Okay, this is the definition of H. याचा अर्थ काय? Look at second row बघा, second row मधून x inverse belongs to Z0 of G, which is equal to singleton E, and x belongs to H for all y belongs to G. And third row काय? x inverse belongs to Z0 of H. Okay, why we taken here Z0 of H? Because Z0 of H is nothing but singleton E. Look at here. Z0 of H is nothing but singleton E. Also, Z0 of G is equal to singleton E. Okay, that's why in the third row we taken Z0 of H. Okay, which is equal to singleton E, and X belongs to H. But this is the definition of X belongs to Z1 of H. Here we taken the element from Z1 of G intersection H, and here the X goes to Z1 of H, which means that Z1 of G intersection H is the subset of Z1 of H. Okay? Any difficulty? काही अडचण आहे का इथपर्यंत?
No, sir.
Okay. Again, suppose that Zm of G intersection H, which is contained in Zm of H for some M. 1 साठी ट्रू झालेलं आहे. आपण काय केलंय? अज्युम केलेलं आहे. M साठी पण हे स्टेटमेंट ट्रू आहे. Okay. So we have to prove that this statement is also correct by using this statement, assuming statement. We have to prove for Zm plus 1. Okay. Mathematical induction सारखं आहे, कळते का?
Oh, sir.
सर
Consider x belongs to Zm plus 1 of G intersection H. What it means? What it implies? It implies x belongs to H and also both x belongs to Zm plus 1 of G. Okay, put x belongs to H as it is here. So what is the definition of x belongs to Zm plus 1 of G? It means that x inverse y inverse belongs to Zm of G for all y belongs to G. Okay, this is the definition. It implies that x belongs to H and x inverse y inverse belongs to Zm of G फॉर ऑल वाय बिलॉंग्स टू एच. जी मधल्या प्रत्येक एलिमेंटसाठी ट्रू आहे, म्हणजे तो एच मधल्या प्रत्येक एलिमेंटसाठी ही ट्रू पाहिजे. वाय? बिकॉज एच इज द सब ग्रुप ऑफ जी. Okay, so it implies that fourth row x belongs to H and x inverse y inverse belongs to Zm of G intersection H. Okay, this is the definition of H मध्ये पण आहे आणि Zm of G मध्ये पण आहे. याचा अर्थ काय? X belongs to H and x inverse y inverse belongs to. This is the definition of Zm of G intersection H for all y belongs to H. Okay, it implies that x belongs to H and x inverse y inverse belongs to Zm of G intersection H, which is contained in Zm of H for all y belongs to H. Okay, इथपर्यंत कळते? ओके, काय कळते का? फर्स्ट टाइम हे हार्ड वाटेल जरा. ओके, सारखं वाचन केल्याने लिहून काढल्यानंतर कळेल मग. Okay, it implies that x belongs to H and x inverse y inverse, which belongs to Zm of H, for all y belongs to H. It implies that Zm plus 1 of G intersection H is contained in Zm plus 1 of H. Okay? Okay, any difficulty? या स्टेटमेंट वरून काय कळतं तुम्हाला? x belongs to H and x inverse belongs to Zm of H. For all y belongs to H, it implies that x is the element of Zm plus 1 H. This is the definition of Zm plus 1. Okay?
Important.
Nilpotent. So x, this is the definition. आता ही जी रो दिसते तुम्हाला फर्स्ट रो, ही डेफिनेशन कोणाची आहे? x belongs to Zm plus 1 of H. Okay? Hence, Zm plus 1 of G intersection. We taken the element from x belongs to Zm plus 1 G intersection H here. But here the element goes to, here look at here, x belongs to Zm plus 1 of H. Okay, म्हणजे हा कोणाचा सबसेट आहे? याचा सबसेट आहे. Zm plus 1 of G intersection H, which is contained in Zm plus 1 of H. By using the mathematical induction, we proved that. Okay, therefore we can write like this: Zk of G intersection H is contained in Zk of H. Okay, hence for all k, म्हणजे मॅथमॅटिकल इंडक्शन प्रमाणे तुम्ही काय केलेलं आहे? प्रूव्ह केलंय. Hence H is equal to Zn of G intersection H is contained in Zn of H. But Zn of H is always contained in which is subset of, कोणाचा सबसेट असणार? तो H चा सबसेट असणार ना. ओके, याचा अर्थ काय? H is equal to Zn of G intersection H. ठीक आहे, लास्टला look at here, first row. Zn of G intersection H is nothing but what? H. Okay, here हेच दिलं इथं. H is equal to Zn of G intersection H, which is contained in काय आलं आता इथं? Zn of H. But Zn of H is always contained in H. It means that Zn of H is equal to H. Hence, we get the small positive integer n such that Zn of H is equal to H. Hence, H is the nilpotent subgroup. Okay, hence subgroup of a nilpotent group is nilpotent. ओके, एनी डिफिकल्टी? पहा, हे स्टेटमेंट नीट वाचा. यातली स्टेटमेंट कुठली कळाली नाही विचारा. ही आधी पहा. लुक एट हियर. हां, चेक करा सगळं करेक्ट आहे का. इफ x belongs to Z1 of G intersection H, it implies that x belongs to Z1 of G and x belongs to H. But Z1 ची डेफिनेशन काय? x inverse belongs to Z0 of G and x belongs to H here. For all y belongs to G, this one. It means that x inverse y inverse belongs to Z0 of H, which is equal to singleton E. X belongs to H, and for all y belongs to h here. Okay, instead of g we can write h, because for all y it means it also true for h. But this is the definition of z1 of h. Okay, ulta baga, if x belongs to z1 of h, it means that x inverse y inverse belongs to z naught of h, which is equal to singleton. Okay, so this is the definition of z1 of h by the definition. Okay, it means that we take an as element from x from z1 of g intersection h, but here x we get x belongs to z1 of h. It means that z1 of g intersection h is contained in z1 of h. Okay, so this is the true for n is equal to 1. And we are assuming for m the statement is true. We have to prove the statement is also true for m plus 1. Okay. So at last we get zm plus 1 of g intersection h is contained in zm plus 1 h. Okay. बघा हे स्टेटमेंट नीट वाचा, रीड करा केअरफुली. Okay. Any difficulty in this up to here? Any doubt?
No, sir.
X belongs to Zm plus 1 of G intersection H. It implies that X belongs to H मध्ये पण असणार, M plus 1 मध्ये पण असणार, Zm plus 1 of G मध्ये पण असणार. Okay, but X belongs to Zm plus 1 of G. It means that, what is the definition of this one? First row, this one is second row. X inverse belongs to Zm of G, for all Y belongs to G. Okay, हे इकडचं राईट हँड साईड असंच ठेवायचं, हे सगळं x belongs to x belongs to x असंच असणार. हे चेंज होत जाणार. Okay, so for all y belongs to g, if this is true, then automatically y belongs to h is also true. Why? Because h is the subgroup of g. Okay, फक्त g च्या ऐवजी काय ठेवलं आपण, h ठेवलं. But this is the definition of x belongs to g, x belongs to h, and x inverse Zm of g and also intersection with h, for all y belongs to h. Okay, हा एलिमेंट इंटरसेक्शन मध्ये कसा आला कळालं? Zm of g मध्ये तर आहे, पण x इनवर्स हा h मध्ये कसा आला? इंटरसेक्शन मध्ये आहे म्हणजे h मध्ये पण आहे. इथे x कुठून आहे? h मधून आहे. y कुठून आहे? h मधून आहे. x y कुठे येणार? h मध्ये येणार. x इनवर्स y इनवर्स कुठे येणार? h मध्येच येणार. मग हा होल एलिमेंट कुठे येणार? h मध्येच येणार. From this we can write x inverse y inverse is the element from intersection of Zm of g intersection h. Okay, it means that x belongs to h and x inverse belongs to Zm of g intersection h, which is contained in Zm of g. Zm of h, sorry, Zm of h, for all y belongs to h. Okay, yes, Zm of h. Look at here. We are assuming that Zm of g intersection h is contained in Zm of h. हे सपोज केलं ना आपण स्टेटमेंट, इंडक्शन हायपोथेसिस अज्यूम केलेलं आहे, तेच इथे यूज केलं. So Zm of g intersection h is contained in Zm of h for all y belongs to h. But this is the definition of Zm plus 1 of h. Okay, x belongs to h and x inverse belongs to Zm of h. For all y belongs to h, it implies that x belongs to Zm plus 1 of h. Okay, from this we can write Zm plus 1. We take an element from this Zm plus 1 of g intersection h, but here we're getting x belongs to Zm plus 1 of h. Okay, it means that for any k, for all k, zk of g intersection h is contained in zk of h. Okay, but we know that h is equal to Zn of g intersection h. हे कसं आलं? Look at here. Zn of G intersection is equal to H is equal to H. Okay. Here H is equal to Zn of G intersection H, but this one is contained in Zn of H by previous step. Okay. But Zn of H is contained in always contained in H. Left hand side la पण H, right hand side la पण H. Okay, it means that the Zn of H is nothing but H. Of H is to hence the nilpotent group by the definition. Okay, any doubt? Induction वापरलं इकडे. To here, any doubt?
No, sir.
Can we move towards next theorem? Next theorem बघायचा.
हो सर. सर
हम्म.
उद्या घेतला तर नाही का चालणार?
का आज काही मन नाही?
जरा
लेक्चर आहे ना आज. ओके, याच्यानंतर डिफरन्शियल इक्वेशन पण आपल्याला स्टार्ट करायचं आहे अजून.
तीच घेणार आहे का सर?
हो या, म्हणून तर 2-2 लेक्चर आहेत ना दररोज. मग ते अर्ध हे अर्ध असं होईल मग. ओके, फर्स्ट टाइम हे हार्ड वाटेल, पण तुम्ही जसं जसं प्रॅक्टिस करून घेत जाल मग समजत जाईल. ते लिहून काढत जा तुम्ही, त्यासाठीच म्हणतोय तुम्ही नोट डाऊन करत चाला. ओके, नाव काय तुमचं?
शेंडगे.
Okay, so look at the next theorem. The homomorphic image of nilpotent group is nilpotent. Okay, suppose G be a nilpotent group with ascending central series. Singleton E is equal to Z naught, which is contained in Z1 of G, which is contained in Z2 of G, up to so on, which is contained in Zn of G is equal to G. ओके, गिव्ह इट एज इक्वेशन नंबर 1. एक शेवटचा थेरम पाहूया, मग बाकीचं उद्या बघूया. ओके ओके, शेंडगे चालेल का? हा एक थेरम पाहूया, मग राहिलेला उद्या पाहूया.
ओके सर.
Okay, look at here. If G is the nilpotent group with ascending central series such that, give it as equation number 1 here. Okay, let again define a function phi from G to G dash with the homomorphism. Without loss of generality, we may take phi is onto. Thus, we now required to show that G is nilpotent. Sorry, G dash is nilpotent. Okay, we shall prove that this by showing that, look at here, phi of zk of G, which is contained in zk of phi of G, which is equal to zk of G dash. काही समजतंय का? तुमचं लक्ष नाही असं वाटतं मला. ओके, ठीक आहे, मग उद्या बघूयात आपण. ओके, डोक्यावर चाललं असं वाटतंय का सगळं?
येस सर.
चालेल चालेल, ठीक आहे, वेट मिनिट.